Spring is the ideal season for undertaking earthworks. On site, some preparatory works have been carried out, others are in progress. The engineer establishes his survey reference grid and sets out the limits of the right-of-way. Utility companies relocate their facilities. Temporary access roads are being established, which will facilitate earthworks movements. The owner has launched a community relations campaign. Information boards and pamphlets and public meetings contribute to informing motorists and local residents about future construction projects. During the design stage, the engineer identified potential spoil and borrow areas. Consultation with a landscape engineer helps him to arrive at possible models of the terrain to improve the project's integration into the environment. Compulsory administrative procedures have been completed by the engineer for the management and the operation of the soil and borrow areas. Bid analysis carried out by the engineer enables the owner to select the contractor. Once the contract has been awarded, the preparatory stage of the earthworks can begin. This stage is of prime importance. Its duration should be specified in the contract. A milestone date is set for its completion. On-site, accommodation for staff and equipment and installations are set up. The contractor digs test pits to confirm the classification of the soil and verify its moisture content. The contractor's surveying staff make detailed surveys of the existing ground and set out the cross-sections. The contractor adapts the earth-moving plan and the construction program. These documents take into account the contract specifications and particularly problem areas, the results of supplementary surveys, the contractor's equipment, likely weather conditions, construction programs for other facilities such as drainage and bridges. The contractor finalizes the quality assurance plan in cooperation with the engineer. To do this, the contractor uses as a base the organization chart from the plan proposed in his bid. The QAP sets out the general site organization and the activities proposed, procedures for carrying out the various tasks, the internal checking plan, and the accompanying procedures, the milestones for each construction activity. This document will be used on site, but may be adjusted to take account of the real conditions of execution. The engineer draws up an external checking plan. Finally, the engineer draws up the quality master plan. This document groups together and coordinates the QAPs of the different participants and the specifications of the external checks. At the end of the preparation period, the contractor will have obtained the engineer's approval of the basic site management documents. The first milestone has been reached. The works can begin as scheduled in the execution plan. The contractor begins to remove the topsoil in the designated areas. The earth is stored in accordance with contract specifications for reuse once the construction is completed. Specific facilities such as sedimentation basins and ditches are built in order to protect the environment. The fill support soils are prepared. The use of geotextiles, drainage layers, and in situ treatments may be necessary. Reusing fill-on soft soils in this valley will require preliminary works. Vertical drains and a drainage layer will speed up consolidation and guarantee stability. Excavation begins with a combination of excavating and hauling equipment that has been carefully selected from consideration of the material to be handled and the transportation conditions. In soft soils of this kind and over short distances, drag scrapers are the most suitable. A backhoe excavator used in association with dumpers is generally preferred for longer distances. Compact soils require rippers. For rocky ground, explosives will be required. These materials are removed using a backhoe excavator or a front-end loader. In the fill area, the material is placed and leveled out in layers. The thicknesses are fixed according to the nature and conditions of the ground and the equipment available in the compacting unit. Where the ground is damp, treating cut or fill with lime will improve bearing capacity and increase the percentage of reused materials. Opening a borrow area is undertaken in conformity with the quarry's regulations and the method defined in the geotechnical reconnaissance study. This source enables fill material supplies to be topped up. A temporary drainage system on site is important if works are to progress smoothly, The contractor must ensure that water is correctly led away from the roadway and side slopes. Groundwater drains should be put in place at various stages during excavation. The upper layers of earthworks play a role in the functioning of the pavement and therefore require special treatment. At the bottom of cut areas, depending on the nature and condition of the ground, it may be necessary to carry out improvement, purges, and replace the soils or carry out treatment in situ. In fill areas, the upper part of the earthworks should preferably be selected fill. Otherwise, it can be treated soil or soils from other sources. Constant attention should be paid to the management of the sources of the roadbed materials. Once the upper layer of earthworks has been completed, the contractor fixes the final level of the road base. The engineer can then check that this agrees with the specifications.
Okay.
Once the milestone has been reached, the contractor begins the construction of the road pavement, which may comprise materials treated in situ or in a batching plant. Or even untreated materials. For this type of important structure, the materials' characteristics are specified in the contract. Materials may be untreated, but in this case, they should be water and frost resistant and have good mechanical characteristics in order to bear site traffic in all weathers. The material may come from quarries or from selected excavation. The material is transported, leveled, and watered if necessary before compacting. The pavement materials may also be treated with lime, hydraulic binder, or a combination of both. The material used will come from cuts on site or possibly from a borrow pit. Where materials are too damp, the water content will be corrected by a preliminary treatment with quicklime during excavation. The preliminary studies identify the most suitable binder for the material in question. On-site, it is imperative to strictly follow the instructions regarding the quantity of binder used, and to control the water content. Mixing will be carried out in a batching plant or in situ. In the later case, the mixing equipment should be a horizontal shaft mixer. After treatment, the pavement capping layer should be adjusted and compacted to obtain a slightly thicker layer than specified. The final adjustment by grading the whole surface will give the layer its final thickness. The accepted tolerance is generally more or less 2 centimeters. A gravel sealing layer, possibly with coated chippings, will keep the base course in good condition and protect it from the site traffic. At the end of the curing period, quality control procedures verify the grading and bearing capacity. If required, tests on core samples will be made. Managing a construction site implies constant vigilance by the engineer. Appropriate tools can help him in this task. Assisted by the quality control unit, the engineer monitors the progress of the QAP and ensures that it is observed. He checks the conformity of works and gives the go-ahead for the important stages of the site, as specified in the QAP. He manages non-compliance by taking corrective measures as planned in the procedures. Concerning quality, it is necessary to record progress and to draw up partial reports in order to promote decision-taking. Throughout the construction, site production is recorded by the engineer using specific computer tools. Interim reports enable the remaining quantities to be estimated. The engineer thus has the means to manage his contract and avoid delays in the work schedule. Measurements made by the contractor are checked by the engineer. The engineer manages his site by simultaneously monitoring the schedule and the earth-moving plan prepared during the planning stage. During the construction, he compares actual site progress with the schedule and makes the necessary adjustments with the contractor. During the weekly meetings, the contractor's difficulties, along with other technical and administrative problems encountered on site, are discussed and analyzed. A summary of all documents produced concerning all aspects of the site enable a document to be constituted, which can then be integrated into the project exception report. This report is prepared by the engineer and submitted to the owner. It serves as a basis for the as-built file and facilitates its management in the long term. For some time, the engineer and the contractor have been working together. The planning, construction, and site management have enabled the earthworks to be carried out in conformity with the required quality objectives. The project has become a reality. The landscape has changed. Soon, the motorists will be able to benefit from this new facility.